Good morning, everyone. Can everyone still hear me fine on your side? If you can just give a comment in the live chat, so I know everyone can still hear me. Thank you, Dave, for the feedback, Wouter. I think we can start this webinar this morning. I want to say welcome to everyone and thanks for joining us with the webinar this morning. Today, I would like to show you how to create a user-defined function block in GXWorks 3. For the guys that's new on with Mitsubishi PLCs, GXWorks 3 is the programming software for the IQ range PLCs. So that will be for the IQF and IQR PLCs. Morning, Johan, and welcome here. So in our agenda today, what we're going to handle is why do we use user-defined function blocks. I'm going to show you how to set yourself a standard for your function blocks. Then I'm going to take you through on how to create a user-defined function block. We're going to test it, and I'm going to show you a way to link your documentation to your function block. So when we want to create a function block, we want to specify what is our needs. What type of inputs and outputs do we require from the function block? Now, I've identified the following inputs and outputs, which I'm going to handle within this webinar. And we will have a look at field inputs and outputs, SCADA inputs and outputs from a GOT, and interlocks. Now we have basically specified our different types of inputs and outputs. We're going to go and see how can we name them in the function block, so that whenever you create a function block, that your naming convention stays the same. So what I've done as an example, for my field inputs, I've made a prefix for F_I. The same with my field outputs, SCADA, GOT, and interlocks. So whenever I write my program, I know if it's a F_I, that will be my field input. If it's a F_O, it will be a field output. So then we need to go and identify what inputs and outputs are we going to use for the function block. Now I've put together a small list for us that we're going to utilize today for our function block that we're going to create. And we're going to create a function block basically to control a conveyor belt. And for the conveyor belt to run, we need to meet certain conditions. So we have an isolator, we have an overload, we have a run feedback from the contactor, we have an interlock, then we have a control panel where we will be using a start push button, a stop push button, a e-stop, and we have an e-stop in the field. On our function block outputs, we're going to require a start signal to energize the contactor. We'll also have a run indication on the control panel with a stop indication. Then I've set up a GOT program for us, which we're going to simulate together with the PLC program, where we'll have a start input and a stop input to the PLC. and feedback from the PLC when we have our run indication, stop indication, and e-stop indication. So now I'm going to take those inputs and outputs and transfer them to labels, so that when we are writing the program and looking at the program, that each and every input and output makes sense to us. So I went and took my prefixes that I've created and add them in front of each label. You guys must just shout in the chat if I'm going a bit too fast, but the video will also be available afterwards for you to watch. Okay, so now we have created our labels where we've created our own standard for how our labels must look like. So whenever you create a function block, your labels has a standard that you are following. So now I'm going to go and open up GXWorks Free, and I'm going to go and create a new project where we will go and start building our first function block. So for my example today, I'm going to use a IQR PLC R04, that is the model of the IQR, and we're going to use function block and ladder programming language. So I'm going to hit OK, and GXWorks Free will create our project for us. Now the project will open onto the main program that's indicated on the screen at the moment. But at the moment, we're not too worried about that. We want to go and create a function block. So if I right click, I can add new data, and we get a pop-up that will ask us to define what the name needs to be, how must it look like for us. We are creating, it's for a conveyor belt, but it's a direct online motor, so no too much fancy stuff in it, otherwise the video will take a couple of hours. So we're going to say it will be a direct online, and this will be version 1. The language we prefer to use inside a function block, I'm selecting function block and ladder. I don't need additional enable for the function block, so I'm going to leave that as no, and I'm going to leave our in the default space allocated by GXWorks Free. So GXWorks Free will create another program for us, and this is where we will be building our function block. Now, important, we've already identified all the labels that we're going to use. So I've taken and copied them to an Excel spreadsheet, which can save a bit of time to go and type out everything. So our function block is going to contain the function block, which will be the... Sorry guys, looks like we had a disconnection there, but it's successfully reconnected. Not sure what happened there. Can everyone still hear me? Am I still active on YouTube? Freddy, can you still hear me? Or John, Johan? Okay, thank you, John. So now that we have identified and inserted the labels into the data file, we can go and close that as we don't need that anymore. I'm going to hit close there. Now, important thing is we'll have to go and register that data file inside our global labels. Now to do that, I'm going to double click on global label, and for this function block we creating, it's going to be for conveyor number 1. So conveyor underscore 1, and now we want to go and link our structured data type. So there you can see my data file is registered there. So I'm going to click on it. I can give it a comment or conveyor 1, and I'm gonna select the extended display. So on our extended display, there's a new tab that it's opened up for us, which where we're gonna go and assign our field inputs and outputs as we are using them on the inputs and outputs of the PLC. So I'm just gonna untick O2 filling. Good morning, Dave. Hope you are well. So we're gonna start with X0, X1, X2, oops, sorry, X3, X4, X5, X6, and X7. Then I'm gonna go and add my outputs. Now because I'm using an IQR, my output card will be allocated on the second slot, but we'll start off at 40. So we'll be assigning Y40, Y41, Y42 for our outputs. And then to communicate to my GOT, I'm going to use internal registers. So I'm going to use B0, B1, B2, B3, and B4. So here's all our inputs and outputs assigned to the labels as we require them. I'm going to click OK there. We'll load everything and we can go back to creating our function block. So when creating your program, it's important to add labels. So when you go back to it, that you remember what you were using in which rung. So we're going to start off by saying we want to write our piece of ladder to start and stop the conveyor. So this will be our direct online start and stop. Hit enter there, and we have a label to start off our program. So if I open our labels here and undock it so that we can see our labels and we can see our program, we're going to need input for the isolator, input for the overload, the run, interlock, and the push buttons, the e-stops. So we're quickly going to create our ladder to suit our labels. So field input interlock, enter field input isolate. Okay, I was meant to put the isolator first, but it's not really going to matter. So we have our interlock, we have our isolator, then we want to add our two e-stops. So those will be field input, field e-stop, field input control panel e-stop. Then we also require a stop from our GOT. Just make sure, yeah, yes. So our GOT sits, the label is registered in our structured data type. So I need to go and reference to that data to collect my GOT tag. That will be our stop from the GOT. Then we can say, okay, we have the isolator, we have the overload, we have our interlock, we have our e-stops, and field stop we don't have in yet. So let me add that. So there's our stop push button. Then we're gonna have a file to start interlock. And then we can start with our start signals. And the first one will be our start push button from our control panel. So that's a field input start push button. Now our push button from the GOT will be in parallel with the field start or the control panel start push button, and that we need to access our database for its label. And there's our start button from the GOT, and I can link that. Okay, I still need to add my output there, and the output will be our MCC start output. And now I can link that up. Now, as the program is at this stage, if I press the start button on the GOT or the field, my output will come on. But as soon as I leave the output, the push button, the output will switch off again. So I need to add a retaining circuit for that. And that will be our field or our output. When that turns on, it must retain my start. And there we have our start and stop function of the function block completed. Now, as I said earlier, we have a file to start input, so I'm quickly going to create the label for that part of the program, and that will be our file to start. And I'm quickly going to add our file to start in. So we're going to say if the output comes on, and we don't have our run feedback, then we're gonna take delay on timer. Just change that to 1 because I've already created a label, and that must switch output for us for that contact that we've placed there. So that will be our start valve contact. I'm just going to link that there. I'm going to link that there, and then we're going to give it a time, how long it must take to time out before the contactor must fall out again. So that will be a T hash, and we're going to make it 2 seconds. And that's all we need for the fail to start circuit. So if our output comes on, this bit will come on. If we don't get a run feedback, the timer will time down 2 seconds, and it will switch on the output, which will stop our circuit again. Now we have our indications for our run and stop and e-stops. So I'm gonna just call that condition indications, and if we start off with the run indication, that will be a normally open contact, and we're gonna take that to a coil. We're gonna add a second coil for the GOT. Sorry about that. And link that up. So for our run indication, we say, okay, if the output is on, then we get the green light that everything is running. So that will be our output. And now our green light on the control panel and the indication on the GOT will be in our database that we've created earlier. So we're going to reference to that, and there we have our run indication. Then I'm also going to create one for the GOT. GOT run indication, and that's all that I need for my run indications. Now I can, so for my stop indication, when the output is not on, then my stop indications must be on. So we can add that, and again we'll say our output. We're going to add the red light of the control panel. Reference that to our database, and there we have our stop indication. And for our GOT. And lastly, we want to see if e-stop is pressed on the GOT. Let's say the GOT is mounted somewhere else in the plant, and we want to see if someone has pressed the e-stop, so that we know why is the conveyor belt not running. So I have 2 e-stops in the field, and they can drive a single output, which will be an indication on our GOT. And there's our GOT e-stop indication, and these will be our field inputs. control panel e-stop and our field e-stop. And we have created the program inside our user-defined function block. I can go and convert it to make sure that we didn't make any mistakes. And I'm not getting any errors, no warnings, and the information tab says that's the amount of space that we still have free in the PLC. Now, as you have noticed in our navigation plane, the function block file is blue. That only means that the function block hasn't been used yet in the program. So we're going to go over to the main program body. We're going to add a label, which will be our conveyor 1. Now there's two ways to access the function block. Now we already know that we've named the function block Direct Online version 1, so I can just type Direct Online, and there's a green symbol in front of my tag there, which means that's the function block, and it also specifies it's the function block. Or I can go over to my function block file, I can click on that one and drag it in. So now it's going to ask me to give it a label, and I'm going to call it function block conveyor number 1, and in the comment we'll say it's conveyor 1. Click OK. Move that up a little bit. Now, if you guys remember earlier on, we've created a data file that will be part of our function block. So we need to go and specify it. Sorry. So let's start off with that. Now, in our global label, we labeled this data file as conveyor 1. So there is conveyor 1. Link it. And it's a driven input and output. So I need to go and place it on both sides. Our output that we're using going to our PLC, we'll go refer to the database, press dot, and scroll down for our output. And I can link that to the function block. Now, if I move the mouse, I've used the wrong label there, sorry for that. There it is. Now, if I move the mouse over this label, what did I do wrong again now? Sorry, let me just quickly have a look here. Okay, I know what I'm doing wrong. I'm selecting the incorrect data file, that's why. Okay, so if I move the mouse over here, it will come up with crap. Did I make the same mistake again? Output. Okay. Now we can see that label is linked to Y40 output, which is our first output on our output card. Now I can quickly go and also assign the inputs to the function block, and we're going to start off with the isolator. So we're going to go conveyor 1 dot isolator. Then we can go to the overload. So conveyor 1 overload. Then we can go to our run feedback. Dot run. Then will be our interlock. Dot interlock. Then we have our control panel start push button. So conveyor 1 start push button. Then we have our stop push button. Conveyor 1 dot stop push button. We have our e-stop on the control panel. So conveyor 1 dot, and the e-stop for the control panel will be the very top one. And lastly, we'll have our e-stop that's situated in the field. So conveyor, and that can be a full wire e-stop. It can be any e-stop that gives protection for someone that's on the other side of the conveyor. If something goes wrong, that they can stop the conveyor. Just going to move the function block, then it links up everything. Now we can go and rebuild our program. And again, we don't have any errors, we don't have any warnings, and the information tells us what space we still have available on our PLC. Now we can go and close that up. Of course, we don't need that anymore. Global labels we don't need. Local labels we don't need. And we are ready to go and simulate our program. Now I've done the GOT programming in advance, and I've set up my simulation software to show you the actual conveyor. So I'm going to switch over to that. So here is my PLC program that I've written in advance. It's already in simulation mode. As you can see, I have functions that's true at the moment. My push button is false at the moment. And I can also bring up for you the GOT that's already in simulation. There we have a motor for the conveyor. We have a start button, a stop, a run indication, stop indication, and our e-stop indication. Now I'm just going to move these out of the way quickly. I can bring up for you the simulation software. And for the guys that doesn't know, this is called Factory IO. It's a simulation software that you can go and purchase from a company in the UK. But we're not here to promote their product. I'm purely using it for simulation. So if I bring up my PLC program and the GOT simulator, then you can see everything in one screen, and I can show you that everything works as we have created it. Okay, I just want to get my screen output quickly. Okay, so now that we have our simulation program running, it's already in the run state. As I can see there, the red light on our control panel is on at the moment. Let's just go closer there. And there you can see there's our control panel e-stop, the run indication, stop indication, the start button and the stop button. Now if I press this e-stop, as you can see on your screen there, the e-stop indication on the GOT came on, and the e-stop input for our function block went off. Now I'm going to reset that, and we're going to go to the e-stop that I've mounted on the conveyor, and we're going to go and press that, and the same happens. We're going to reset that. Now we can, if I press the stop button, you can see on the function block simulation that the stop input falls away, and it's healthy again. And now I'm going to start the conveyor. As you can see there, our conveyor is running. We're getting pallets through. Our run indication on the GOT is on, and I'm going to just quickly go and test all my inputs. So if I press the stop, the conveyor stops, and I'm just going to start it again. If I press this stop, everything stops, and I'm resetting, pressing start again. Now I'm going to test my stop push button, and there everything stops again. Now I'm just quickly going to go and show you guys the GOT. If I press stop, then my conveyor stops. You can see the stop indication. If I press start, my conveyor starts up again. So I'm gonna just stop this so it doesn't make noise while I'm busy talking. And that is basically it to create your user-defined function block. Now, with our function block, we can also create a document to explain what our function block does. As you can see on the screen, I have a picture of the function block as we can see it in the PLC program. Then I basically went and defined my inputs, my outputs, and my data file that's inside of the that I've created for the function block. I've also added the descriptions and the type of bits that's being used. Now, for our program, everything was bits, but you might have some words and integers or floats that you're using to display analog values and so forth. Now, if I go back to our program that we've created earlier on, I want to show you how to connect this document to your actual function block. So I'm going to bring back our program to the screen, and if I select the function block, I only see the following tags on top here, which is a delete, a cut, and a copy. Now, for our function block to be used effectively, we want to go and give a bit more data on our function block. So I'm going to go and select a function block in our function block file, and I'm going to go to its properties. In the properties pop-up, I can go and give my function block a title, and this one is simple. It's just Direct Online version 1. Yeah, also I can go and specify the version of function block that I'm using, and now it gives me a tab where I can go and upload a document that supports the help function for the function block. So if I press OK there, now you can see we have another icon up here, which will be our help. If I press on our help there, we'll open up the document, and we have everything as we have created our document. So I can go and close that up again. So now we have created the function block, we've created the document to support it. I can go ahead and drag this function block into our program 500 times if I have 500 conveyor belts. I don't have to go and write the program over and over and over. So that's the advantage of using function blocks. And we're keeping to a standard that we've defined previously. So if you guys have any questions that you would like me to answer, I'm more than happy to answer them for you. I'll answer them to my best knowledge. You can also email me directly, or you can contact our office and you can speak to one of our support engineers, or you can ask for me directly, and I can assist you to move forward and build your own library where you have function blocks for your conveyor belts and the control of valves and so forth as you need them. So please, if there's any questions, you're welcome to go ahead and ask me. I'll stay online for a bit. So in case there's anything, otherwise, as I've said, you're welcome to email me, and we will also be able to answer you that way. For the rest of you that wants to leave at the moment, thank you for joining us. I hope you guys have a very good weekend. All my contact information is on the screen, my email address, our office number. So I hope everyone has learned something today, and that you can take it out to your workplace and increase your productivity when it comes to programming. Thank you very much, everyone.